All right, let's get started. My name is Allard Buijze, and I'm going to complain / talk about the pragmatic approach, or the lack thereof sometimes, of building microservices. At the moment, I'm CTO of Trifork Amsterdam, and I'm also the founder of Axon framework, and it won't be strange if I tell you that I'll be talking about and showing you some Axon related stuff. While preparing my slides, I realized that nothing I say or do in this presentation would be better off with slides, so I decided to do no slides at all and just keep to a live demo, actually, and live coding as well. So instead of just talking about a microservice environment, or a system of how would you call that? A system of microservices. Let's just build one, right? How long could it take to build something like that anyway? We've got plenty of time today. But what I've realized is, or what I've noticed, is that as soon as a new project starts, I have the luck to be involved in a lot of greenfield projects. A lot of the discussions are about, oh, what technology should we use? Shall we use Hystrix, or do we? What discovery mechanism will we use to discover the 200 clients that we have, or the 200 components that we have in mind right now? So everything is about what technologies are we going to throw at our solution or problem to make it technically really interesting. But in the end, that doesn't really help in achieving the primary goal that those people have, and that's get customers. Right? If you have a greenfield project, the first thing you should worry about is get the logic out, get the business logic working, and see if anyone wants to use it. And only when people start using it, then you fix the scalability problems if they come up. So what I'm going to show you is I'm going to use the Spring Initializer to create a little project. And I'm going to show you how Axon keeps the business logic and the infrastructure logic separate. Because scaling up and down should not change how your application behaves. Right? So the business logic itself, the problem you're trying to solve, is the same one. It's only the scale at which you're trying to solve it that might differ a bit. So a very important aspect in Axon is location transparency. Objects or components should not care or even know where other components that they use are located. Are they in the same VM? Are they on a different VM in a different data center, wherever? It doesn't matter. They shouldn't care. Right? So what we're going to do is build a little application where people can file complaints. The ones that were in the room early probably saw that I had to reboot my machine, so I need a place to complain about Microsoft and especially Windows 10. So let's build one. Right? There probably is a place already, but this one's going to be better. So we're going to use Spring Boot to get started quickly. I'm going to include web. We need a relational database. We'll use JPA, not because it performs, but it gets us started pretty quickly. And I'm going to do some AMQP stuff later on as well. Now let's hope the internet works, otherwise we have something else to complain about. And then we unzip that file, and we start the project. That should start the project. Great. Give IntelliJ some time to think about what it should do. There we go. Who's not familiar with Spring Boot? Well, you are now. Spring Boot is, who of those people is not familiar with Spring? Just a few, all right. So I'm not going to explain all of Spring and Spring Boot, but at least Spring Boot gives us Spring with additional, well, some call it magic, I call it auto-configuration, that configures our application based on dependencies that we have or do not have on our class path. So in this case, I've included JPA and AMQP and HSQLDB. So it configures everything I need to use JPA and HSQLDB for me, so I don't have to think about that. And I've included web, so it's actually a web application. I can just start this class, and I'll have a web application that does exactly what you see here, nothing. So let's build something. Let's start with a, I do that all the time, REST. Let's create a REST controller. We need an API for our users to file the complaints. I'm going to be a very lazy and bad developer to put everything in the same file here, almost everything, but that's just because it's very easy to do. So we're going to create a little controller, and we create a method that gets invoked. That gets invoked when we do a GET request, right? So GET requests are mapped to this method. And we could say we do a findAll method that gives us all the complaints that we have in our system, right? So we need some form of repository to retrieve all the complaints that we've created. But we're going to use CQRS, which is the command and query responsibility segregation pattern. So we're not going to have a single model in our application that we query and update at the same time, but we're going to separate those. We're going to have one component that deals with the commands that we send, and we'll have another component that sends out the information as things happen in our application. So if we want to know something about the state of our application, like this findAll method, we go to a view model, a query model, which is optimized for serving out that information as fast as possible. Our database here won't have massive amounts of complaints, but you can imagine if you put this in production, I mean, I'm Dutch. In Holland, people love to complain. There's actually an organization that does this. You know, they have an application like this. So we need this place to complain. So that database gets really big, and you need to be able to query that efficiently. So let's create a complaint query object repository. And of course, that doesn't exist yet, so let's create an interface. And this is where Spring Data JPA comes in really nicely. We extend a JPA repository of complaint query objects identified by a string. That's it. No, that's almost it. That's it. So this gives us a JPA repository. Now we create a little class here, which is a JPA entity. And it has a number of properties, a complaint ID, a company that we want to complain about, and a description of the actual complaint. And then create some getters, a constructor, a no arg1 because it's JPA, and an all arg1 because it's me. That's it. Now we have our repository, and all we need to do now is repository.findAll, and then return that. There you go. So this is all we need to do to create a little REST API, if you will, to map get / to get all the complaints. So we could create another mapping. Whoops. To complaint query object find one at path variable string ID. We get one by identifier. And now we need to specify a URL here where we say we have a path / something, and then that something will map to that identifier, which is the identifier of the complaint we want to fetch. But that's not really the interesting part. This is probably something you've been, if you're not one of those people raising their hands, probably something you've used before. It gets interesting when we start doing the post mapping, because now we're going to tell the system to do something, right? And since we are applying CQRS, that's command and query responsibility segregation, we're going to treat these commands differently. We're going to have a different component handle this. And we want the location transparency that I told you about, because we are not sure if this component is going to be living with the UI component forever, right? So let's do a void for now, file complaint. And we're going to use an HTTP post for this, and I don't want to make more objects. So we just create a map. Spring will convert the JSON document that we post to the map in here. And now what we need is an Axon command gateway, which is not giving me because I haven't added the Axon dependency. Ooh, it's nice and slow. Axon Spring Boot Starter. There you go. All right, so let me create a little constructor here. The command gateway is a convenience class that allows us to send commands, basically. And because we have included the Spring Boot Starter now, it will auto-configure all the components that we need for Axon to work in the background. So it has given us a command bus, which is the mechanism to get commands from whoever sends it to whoever needs to handle them. There's an event bus as well. There's an event store that stores all the events that we've created, and we'll get to that later. But it also gives us a command gateway, so we can just auto-wire the command gateway in here. For those not familiar with the new Spring 4 features, you don't have to put auto-wired on these classes anymore. If there's a single constructor, it will just auto-wire the beans in there automatically. Anyway, so we want to send a command on the command gateway. And in Axon, commands are objects, right? They're messages that we send as objects from the origin to the destination. And that allows us to be location transparent, right? We do not care where the actual recipient of that message is. They're a lot easier to serialize and send than method invocations. And method invocations always give us the idea, especially for things like find all, there's a return value here, which forces us to wait for that result to be provided, right? So if we use send and then a message, we can just fire and forget. Let's create a file complaint command. And we pass in some information. We pass in an identifier. We get an object, the company, and we get a description from there as well. Now, I like client-generated identifiers for a number of reasons. So I'm going to specify the identifier of an object I'm going to create. And that might be quite uncommon. It might even look weird. I'm using random UUIDs in this case because they're very safe collision-wise. But it allows us to send more commands in a row for the same object. What if you want to create something and then update a few things in a row? You don't have to wait for an identifier to come back and then send the next message. You can just send them all in a row and not have to wait for it. Actually, this does have a return value. So let's create this class. We'll create an inner class like that. It does have to be public. And as you can see, I'm letting IntelliJ do most of the typing, because it can type a lot faster than I can. And then have that return, so it's actually a string, probably doesn't matter. So this gives us an API, a REST API, in which we can file a complaint by doing an HTTP post with a request body, and it allows us to retrieve those complaints through an API. But of course, there's a command going to the void, right? There's nothing handling this command. We've just specified there's an object that we want to send, but there's nobody actually listening to that type of command. And that's where it gets interesting. So CQRS is an architectural style, but in practice we see that it's applied in combination with domain-driven design a lot, because there's a lot of focus on modeling these different sides of the application, right? And especially on the command side, you want to be quite efficient there in handling these commands and deciding what the actual changes are. So let's build what's called an aggregate. And an aggregate is a group of entities that together act as one unit when with regards to data changes. So if something changes, the aggregate itself is always in a consistent state, no matter what happens, right? And in CQRS, the aggregate makes the decisions based on these incoming commands and based on what happened in the past, or the current state of the aggregate, on what will happen when that command comes in. In our system, we can just file complaints, so there's not a lot of business logic going on. But as you add more commands, you'll very likely find yourself validating the commands based on the state of the complaint. For example, you can only close a complaint if it probably needs to be resolved first, and then you can close it. Or maybe people need to take specific actions based on a complaint before you can resolve it, etc., etc. So let's create a little class called complaint. There's one mandatory field on an aggregate, and that is the identifier. Identifier, there we go. Now I'm going to create a constructor. And that constructor is going to be a command handler. So that method, or in this case constructor, is a handler for the command that we're going to send above, which is the file complaint command. And this is our way of saying that method over there can handle this type of command. We don't really care how that command comes from that one place to the other place for now, right? The Spring Boot auto configuration with Axon together will give us a simple command bus, which will do the routing within the same JVM for us. As soon as we want something else, you can override that default and specify how you want it done. But it's not our primary focus. First, we want the business logic, and we want to get our first customer to file complaints. Now I'm going to apply a little thing called event sourcing. Is anyone not familiar with event sourcing? Anyone not feeling like raising his hand? Okay, I've tried. Yeah, so okay, that's great. So I'm not going to explain all that, which is a good thing. So what I'm doing here is I'm applying an event. I'm going to apply a new complaint filed event. I'm going to pass in some data from my command, hopefully in the same order as below. Yes. And then, of course, I'm going to have that object created. Public static. Actually, I'm going to move that one out. Like that. All right, some getters, and there we go. It's a very simple object. It's very similar actually to the command, but I like to. I mean, code duplication is heavily debated nowadays, and it's apparently not that bad to actually duplicate code, because they do mean two different things, right? My event is definitely different than my command. So any tool telling me to make that one class gets kicked out of whatever. I don't want that in my IDE. There are two different objects, and they happen to have, at this point in time, the same fields. But that's probably not going to be the case after the second or third iteration of our little project. So let's do a little bit of validation. Assert dot has length command dot get company. Right. So what I should not do, and that's very important, is in my command handler I should not modify any fields. I should not modify any state in my aggregate, because those modifications are not going to be applied when I reread my aggregate from the historic state, which is event sourcing. Right? So what I need to do is have a separate methods that do apply these state changes, but then based on the event. So what does it mean for this complaint instance when it has been filed? It means that the identifier is set to the value in that create event. Right? So when we reload a complaint based on the historic events that have occurred, well, they're historic, so they have occurred in the past, when we reapply those events to reconstruct the current state, we invoke the add event sourcing handler methods. Right? We're not going to invoke any of the command handler methods until it has been loaded, and then we generate new events. So that's it. That's all we need to do to create, in this case, the business logic to handle the command and then generate an event. But now we have an event leading nowhere. Right? We haven't still gone full circle on our little API here, so we're sending a command out. The aggregate will be handling that command, making a decision. If it likes it, if there's a company name in there specifically, then we generate an event. But now that event goes nowhere, and we still haven't updated our data, here in the repository, right? So let's do that now. Let's create a little add component. That's a Spring component. Complaints query model updater, and that has an event handler. And when a complaint is filed, what we want to do is we want to update the repository. And get some data from here. Get the company and the description. So this will store a new query object, which is basically a DTO, to get data out as fast as possible into our repository every time a complaint is filed. Now this is something that we should be able to run. And now the question is always, what did I forget? So we'll see in a second. Nothing so far. Can you read this? There we go. Curl. So we're going to send a little post request. Content type. Make one typo here and it doesn't work. Okay. -D, and then we're going to send a little JSON document containing a company, Microsoft, and then a description of needed to reboot again. There we go. I'm pretty sure they'll be reading this. Can somebody take a picture and put this on Twitter, @Microsoft? Okay, and I always forget the URL, localhost 8080. There you go. Ah, see, I forgot something. I always forget something. Yes. So even Spring is not magic. You need to set the repository to a value if you want to use it. There we go. That's it. Now we should be able to go to localhost 8080 and get all complaints. Let's make that a bit larger. There you go. So now we've gone full circle, and this is all within the same JVM, right? But at least we got something up and running pretty quickly. If you have used Axon before, especially the 2.4 version or 2. Whatever, you probably remember the times where you needed to specify the command bus, event bus, repository, command handler, annotated aggregate command handler stuff, I don't know what. All that's gone. You just get everything out of the box and for free. But we're still in the same JVM, and this is not really a very inspiring environment, right? It's hardly a microservice. Well, it's one microservice, or micro monolith, if you will. So, of course, there's always this management thing, right? These managers want to be able to see statistics, right? They don't care about the details. They want to see the big picture. So it's only a matter of time until they come with a request. Okay, well, I want to see how many complaints we get for each company. Right? Give me the top 10 companies that are being complained about. Now, we could put that in our micro monolith and make it a slightly less micro thing, or we develop it somewhere else, which is, of course, much more interesting. So let's do that instead. To be able to do that, I need to get the events that we generate out of this virtual machine. We want to get them somewhere else. As you've seen on the Spring initializer, I included AMQP, which is the Spring AMQP configuration. Unfortunately, yet they don't include Axon AMQP there yet, but that's done in no time. And then I can tell Axon AMQP.exchange equals to forward all the events to an AMQP exchange. Now, who's not familiar with AMQP? Okay, a few. Yeah. So in AMQP, it's a message broker, right? And it has a number of building blocks that you can use, mainly exchanges, bindings, and queues. And an exchange is something you send messages to, and the queues is the place where you read messages from, right? So every message you send to an exchange will have a copy put into one or more queues, depending on the binding, right? So the binding links the exchanges to the queues. So complaint events. Let's call it complaint events. Now I have to do a bit of configuration in my Spring Boot application what was it again, bean, public, queue. Come on, import the right one. We'll overload a term, queue. Queue builder dot, let's make it durable, queue, complaint events. The name doesn't really matter that much. Dot build. There you go. Now I have another bean, oops. Public exchange. Guess what, there's an exchange builder. And we're going to choose a fan out because it's the simplest. Exchange there is. Complaint events. Let's give everything the same name just to make it really confusing. And then we need a binding to link the two. Guess what? Binding builder. We can bind our little queue to our exchange with, and the routing key doesn't really matter in this case. It tells us which events do you want to send to that queue that you're binding to. We want everything. So this allows our application to use these queues and exchanges, but it doesn't create them. We need to specify that we need to create those queues as well. And there's a little bean called AMQP admin. And this is our AMQP administrator, so we can define queues that we expect to be there when this application runs. So we're in a little DevOps environment. We're not going to create our document and then write a Word document, or create our application and then write a Word document for the deployers to deploy. Oh, and remember, before starting the applications, please create a queue like this and an exchange like that and bind like this. No, we do it in code, right? So we declare a queue. Whoops. What am I doing? Declare queue. Declare exchange. And I declare binding. So make sure you do it in the right order. Don't define the binding first, because you're going to bind a queue and exchange that don't exist. And restart. So this will allow us to, well, this will actually send our messages to the exchange and place them in a queue. So let's file a complaint again. It's an in-memory database, so we've lost our complaint so far. Let's complain about Apple as well. Otherwise, it's only Microsoft. That's not fair. Apple description. Guess what I'm going to complain about? Prices? I was going to do this. Okay. I'm missing a hell. Oh, don't do quotes. I am missing a hell of a lot of stuff on my expensive machine. Please send USB port and escape key. There you go. That's all we want, right? A USB port and an escape key. That's all we need. All right. Let's see what happens. So I've got 2 complaints. So I restarted, so my in-memory database has been cleared. So now we just have an expensive machine and a machine that you need to reboot all the time, but at least it's not that expensive and it has an escape key, right? So pick your battle. Now let's have a look at our RabbitMQ. Oh, wow, that's nice and big. At least we have a queue, and there was a little spike, and let's go into the queue and see. We have 2 ready messages. Right, so there's 2 messages waiting. Guess which they are. But of course, we don't have an application to read them out of that queue. And we could build that in here, but that's not fun. So let's not do that. Let's go back to our Spring initializer and create a little application, complaints, statistics. I hate that word. Statistics. There we go. No. All right. Demo. Ah, come on. And we open that project. So it's amazing how many legacy projects you can create in 30 minutes, right? All right. Just imagine how many you could create in a training session, which could have been tomorrow. But so what do we do here? Well, we need a component that deals with those events, right? So we'll have an event handler here. We make it a Spring component, public, static class, And this is our statistics updater. And let's be really lazy. Let's make this immediately our REST controller as well. We just do everything. That whole idea of layers in your application, just forget about it, right? We put everything in one class. What do we care? It's legacy anyway. Our event handler is not here. That's because I need to include Axon. Oh, come on, help me out. And then Axon AMQP. There we go. Public void on or handle. The name of the method doesn't really matter as long as we specify the event. Now we have a little API problem here, well, a problem, challenge. Of course, we need that event object, otherwise we can't compile our code here. And of course, we all know, and this is very common in software projects, you just send it over email, right? Okay. Now, normally you would have a jar or something with dependencies, or even better, to have a documentation of the structure, the serialized form of the events you're going to transport. So if you serialize them using a JSON serializer, for example, Jackson, you would share how these documents are structured and actually put on an AMQP queue. But since sender and receiver are both Axon-based, we might as well use these objects and these Java objects. And then we have complaint file event. Just make sure they are in the same package. If you do that copy-paste little thing, so if you send an email, specify the package that they need to place the stuff in. All right. Now we need to update something. Let's create a little private final concurrent map, well, just because we can. And we'll create a map from strings to atomic long, which is our statistics. There you go. And now we can say statistics.compute if absent for our event.getCompany. And we create a new atomic long, which we then increment and get. And of course, we need a get mapping so that we can actually get the statistics out of our elaborate database. There you go. That's it. So this will allow us to handle that event, and we have a get mapping where we can go and read the statistics. But guess what? When I start this application, Axon does not magically know I'm going to read the messages from that one queue that we've created, an AMQP, and then pass them on to here. So what Axon does is it combines event handlers, or at least the classes containing event handlers, in so-called processors. And every processor has a source where the events it will process come from. By default, the name of the processor is the package name, so in this case it would be com.example, which is not a very good name because the other project uses the same one as well. So we can specify a processing group with an explicit name that we want to use. And let's call it statistics. So now we have all the event handlers in that method being dealt with in a group called statistics. And now we can tell Axon the statistics group should receive its messages from a queue instead of the default, which is the event bus. Now we do that in here, and I have a little cheat sheet because I always make typos. And we could say the processor, actually called statistics here, the source of that statistics processor is, and then we specify well, this is actually a B name. Let's call it statistics source, which is a B name which specifies the source. So the default actually here is event bus, right? But we don't want that in this application. So we need to be able to specify that source, which is a Spring AMQP message source. return new Spring AMQP default serializer. Do some auto wiring. We add a parameter. Yes, fine. There you go. So we specify a message source which reads from AMQP, but this message source doesn't magically know that we want that queue. So we need to specify a, what's it called again, simple message listener container, something in Spring. But the reason I hardly remember that name is because you don't really need to use it. There's another way. There's a little trick you can do. We can override this, this method in an anonymous class and then just say at rabbit listener queue equals complaint events. And what happens now is Spring will make sure this method is invoked when a message is received on that queue, and then Axon will take on, because of the supercall, and make sure that all the processors that are attached to that specific source will receive the message. I was about to start the application, but I almost forgot to choose a different port, because there's the other application running on 8080. Let's see what happens. Right. Well, there's no messages anymore. There you go. And we have our statistics. Management happy, we're happy. Customers aren't happy because they have many more complaints, especially about all these USB ports and escape keys missing. And in the meantime, we see all that stuff changing. So what we've created here is an application that separates, well, not really because everything is in the same class, but at least the logic. So this is our business logic, right? When this thing happens, then I want to act on it in this way. And then somewhere else, we define, okay, how do we actually get that event to this virtual machine or to this JVM, right? So that's all separate configuration. So we can change all this, and we can copy this, this class into the other application, remove our AMQP stuff, and it will still work in exactly the same way, functionally at least. Technically, it will be different because everything runs in the same JVM. We could also, but I think time is almost running out, but we could also include the JGroup starter in this application and have two nodes handling the commands and sharing the load between them. And again, all we need to do is just change a bit of configuration. We do not need to change any of the, let's go back to that other project, any of the command handling, right? The logic here for handling how we create a new complaint doesn't change simply because we have our application deployed on more than one machine. So that concludes my live demo. I'm going to find a place to host this and then put it online. And okay, thank you.